testing, and what was the thing that we didn't talk about hypothesis testing last time? We did what? We compared the population mean to the sample mean. Did we discuss whether we should reject or not, or did we just kind of speculate on the rejection process?
We did.
No, we used common sense. Whatever we're going to use now instead of common sense. Math. And I said in the last question more specifically, wait, what? Providence. That's it. Oh, confidence. Okay. Confidence and probability, not Providence. That's in Massachusetts. That's Rhode Island. That's so close. Sorry if I offended somebody that's actually from there. Okay, so here we're going to investigate our red wine example, and I do apologize if you've never had red wine before. But we don't really need to have red wine for the example because we're looking at prices. We're not looking at tastes of red wine, we're looking at prices. So we're going to assume that the mean price is 15 and standard deviation is 21. What I want us to do is do a little bit of review, finding both the mean and standard deviation of the sampling distribution for size 36 samples. So I gave you the sampling distribution for size 36 samples. Let's go ahead and write the mean and standard deviation and whether or not it's normal super quick. This is review. Let's have a chance to remember the mean and standard deviation and whether it's normal. With the correct symbols. Terms? What do you mean by terms?
Oh, never mind. Sorry, never mind. No,
Of the sampling distributions, we need a little X bar on to the side, a little subscript with a little X bar because it's a sampling distribution. This is a chance to review. Do you remember what a sampling distribution is? Okay. You guys are going to be like, oh, I knew that. And maybe Audrey might be like, isn't that implied? It is, but I do want to see it on your papers. Okay. The mean of the sampling distribution, the symbol for that looks like this. The standard deviation of the sampling distribution looks like this. This is what I'm asking for in the problem. What's the mean? 15. Is the standard deviation 21?
No, you can divide it.
Good. You have to divide the 21 by the square root of 36. That's 21 divided by 6, which last time you remembered is 3.5. And why is this sampling distribution normal? Does anyone want to share that information with the class? Good. The mean is coming from size 36 samples. 36 is above 30. So, therefore, it is normal. I want everyone to write that down. I'm not going to write it. Make sure to answer it. And sorry, I'm being a little extra sassy today. So I said, instead of doing a cartwheel, because I feel like all of us could probably do a cartwheel.
Fine. No.
No? Anyway, what I said is I'm going to put together a bar because that's a little bit more unique.
Yeah, that's really
Although I feel like everyone can do that too in practice. I started as a kid, and I think we can all still do it. Just like we can all do math. Okay, number 2. I'm looking at different sample means here. 4 different samples, each obtained from different samples of size 36. The first one had a mean of 8, second one 15, third 18.5, and the fourth one 25.5. Want us to put these in the order from most likely to least likely obtained. Now we have the sampling distribution over here. So we have to use the sampling distribution information to put these sample means in order from most likely to least likely. think, pair, share. We're gonna do this individually first, and then we're gonna do it in partners and then as a class. Okay, you got it, but that's numbers. That's easier for me. Looking order, so 1, 2, 3, 4. So that's also they put a 1. Yeah, that's right. Okay, I think we've done a really great job on this, so I want us to start sharing our answers. Okay, what's the most likely one?
15.
Good. I'm gonna put a 1 in the box that says 15. Why is this one most likely? Good, the population mean is 15, so we see that most of the sample means are gonna fall at 15. That little peak there says most sample means fall at 15. That's why it peaks off at 15, and then it levels off on the side. Very good. Okay, what's the second one? Good. How come 18.5 was the second most? Good, it's the closest to 15. So if you look up here, it's still kind of likely because there's still some sort of height on the curve. Very good. Okay, what's 3? Do we all agree that it's 8?
Yes.
Yes. Okay, if we look at 8, it's further away from 15. And if we look at its height, it's very bad. But 4, obviously by process of elimination, is 15.5. Should you even get a sample mean of 15.5? No, it looks like the probability of getting the sample mean of 15.5 is 0. Yeah, I need to read that. Thanks, Lauren. So, if your population mean is truly 15, it's pretty much impossible to get a sample mean that's 15.5. Very good. Let's go ahead and find the z-score now of each of these sample means using the z-score formula. We have the population mean here and then the population standard deviation. Now the z-score formula, if you forgot it, I'm giving the general one. The general z-score formula is x minus mean over standard deviation, but we want to find it for x bar, so these are going to be slightly different. It's going to be slightly different. Go ahead and find the z-scores for each of those. And it's no coincidence that I picked these 4 values. In fact, you should get whole number z-scores. If you don't get whole number z-scores, you're doing something early.
Can you maybe pressure? It's on the bottom of standard deviation, the x bar.
Here's the original z value formula. We want to modify it for x bar, but remember, yes, pretty much, yes.
But it is still minus the mean.
Yes. So minus the mean, make sure you make minus the x bar mean, divide by the x bar mean.
Yeah, so it's x bar minus mean.
Which is 15.
Divided by 3.5.
Yes.
Heck yeah.
Don't divide by 21, divide by 3.5.
Wait, we should get whole numbers for all of them?
All 4 of them should be a whole number. They can be negative though.
Okay.
Unless I screwed up, either
Because
right?
this one I got is 0.16.
Okay, we have to be divided by 3.5 here because we have X bar that we're finding the z-score for X bars. We could also look at this logically and see that we added one standard deviation to get from 15 to 18.5. Why is it one standard deviation? What do we add from 15 to 18.5? 3.5, so the z-score is 1, because you added one standard deviation to go from 15 to 18.5. In fact, I'm going to do it the logical way. I'm not going to do it the other way. Okay, I think we should go over our answers. The z-score is the number of standard deviations away. How many standard deviations away is 15? 0. 15 is the mean. It's 0 standard deviations away. Okay, 18.5. How many standard deviations are you adding? 1. If we look at 18.5, you're adding 1 standard deviation, which is 3.5, to go from 15 to 18.5. So this one's 1. Okay, 8. Good. If we look here, you have to take 7 off to go from 15 to 8. That's 2 standard deviations below. So that one's negative 2. And 15.5 is 3 standard deviations because you have to add 3 standard deviations. Oops. Yeah, 3 standard deviations to go from 15 to 15.5. That's 10.5. We could have also used the formula and we could have done 25.5 minus 15 over 3.5. That would have also given you 3. Okay, any questions on how I got the z-scores? Okay, let's try number 4. A sample mean with z-score blank is more likely to be obtained than a sample with a z-score closer to blank. Okay, group, think, pair, share, individual, partner, class.
Which z-scores are more likely? Does your big question is it's more likely to be z-score?
Sure. Okay, my bad. Erica caught my mistake. This should be further. I changed it. That would be kind of important. Okay, I'm just going to give the answer. Where should the sample means be? They should be with z-scores by 0. Okay, good. So this one is sample mean with z-score closer to 0 is more likely to be obtained than a sample mean with a z-score further to 0. I wanted to keep these both 0. Okay, now we're going to do the hypothesis testing. And So when are we gonna, let's kind of speculate on rejection. We're gonna reject when our sample mean is further from zero, is what we're gonna find out. We shouldn't be getting sample means that are far from zero. They should be all close to zero. So let's do number 5. Let's now construct a null and alternative hypothesis. And we're looking at this one here. We were assuming the mean is 15 and the standard deviation is 21. And then we're looking at a random sample of 36 red wine bottles, and it gives you a mean of 25.5. Let's construct a null and alternative hypothesis for a two-tailed test. So we learned this in the last homework. So let's set up null and alternative hypothesis and make sure you put the right values. It's tricky. Remember that the null hypothesis is an assumption. Okay, think, pair, share. I'm gonna go around the room. Null hypothesis is different assumption. Are we assuming?
Yeah. Wait, it's not 25.5?
It's not 25.5.
We just make it random.
No. It's, yes.
So isn't that like it's no?
Exactly.
So we done?
Yes. So two-tail. Two-tail is not equal to.
Right.
What did you get? Yes.
No, it's not.
Okay. I'm going to explain. Why is it 15 and not 25.5? There's two reasons. Okay. First of all, this is the population mean. We always do hypothesis testing for the population mean. We go to the top. The population mean was 15. See, assume the price for a bottle of red wine has a mean of 15. What's the second reason? Let's get out our notes from last time. What is a null hypothesis? What was that big definition where we were trying to unscramble all those words?
Oh.
An initial assumption. Which one is the assumption? Is this one the assumption, or is the 25.5 assumption?
15.
15. Why is the 15 an assumption? It says it at the top. It says assume that the mean is 15. Why do we have to assume that the mean is 15? How come I can't say it's actually 15? Good. How much data is going into the 15 if it's a population? That's a sample of 36 bottles. How many bottles are there of red wine? Is there just 36 bottles of red wine? There's way too many. There's probably millions and millions and millions of bottles of red wine. It's impossible to figure out if the mean from all those bottles of red wine is really $15. We are assuming that it is 15. We will not know for sure. However, we can take our sample, and the sample gave us the 15. What symbol do I want to use for 25.5? What symbol goes here? So mu is 15. Mu of x bar is also 15. This is a sample mean. What's the symbol for sample mean? That's sample proportion. Yes, the 25.5 is a sample mean. Come on, guys. You guys know it. You're just over. It's just x bar. Okay, it's two-tailed, so the alternative is that the mean is not $15. Okay, should we reject null hypothesis? Explain. Think, pair, share. individual, this is actually an opinion. Look at your information that you have from the top of the page to make your decision whether we should reject the null hypothesis or not.
They're saying we should have the rest.
So the sample was 25.5.
It's like, yeah, so like, you can't reject it because like it's such a really, actually, we should. No, it's because, I think it's.
So assuming the population study continues, our sample means we won't get one.
Right.
It's larger.
Yeah.
It's likely to get it. Sample.
So, yes.
See what David wrote. I want some really good explanations here. Why did you guys say that?
The sample mean is $10 more expensive.
Yes, and we can be a little bit more specific than that. It fell all the way over here,
Yeah.
which is not likely. Okay, let's do a yay or nay poll everywhere question. Well, you know what? I don't have poll everywhere loaded. Okay, let's just do an embarrassment, raise your hand question. Okay, how many of us vote yes, we should reject? How many of us vote no, we shouldn't reject? I'm gonna vote no. Are you sure nobody else wants to vote no? Okay, I should have fall for my trap. Not that it was a trap. Yes, it's yes, we should reject it. Why should we reject it? Does anyone know? Let's look at, okay, yes, Lauren.
Well, if it's not like we have 25
Exactly. If our population mean is really 15, we shouldn't be getting a sample mean that's 25.5. What's the likelihood of getting the 25.5 if it's all the way over here? There's pretty much a 0% chance of getting a sample mean that's $10 more expensive. So you should reject this population because
it's too far away.
it's too far away. It's 3 standard deviations away. That's too far away. Excellent. Okay, so this is called the critical value approach. When we reject the sample mean, when it's a certain number of standard deviations away, in this, or we can be more specifically, we can say 100 alpha% most extreme values. And so it turns out that 25.5 was in the alpha 100% most extreme values. We can be a little bit more specific. Let's look at the z-score for the 1% most extreme values. We're going to do it for a two-tailed test first. So let's see if we can find the 1% most extreme values. Where are they going to be on the graph? So let's shade the 1% most extreme values and then find the z-scores for the 1% most extreme values. So, and then let's do it for the left-tailed and the right-tailed. Okay, I think pair share. Let's find the 1% most extreme values. You need Excel, yes. No, it's not right here. That was the z-score. Just to see how we can sort of speculate.
I'm trying.
We shaded that, so it's whole thing is 1% shade.
So the mean is 25.5.
Yeah.
Are we going?
We're creating the boundaries, the 1% most. The 25.5 had to do with 3 standards.
I thought, okay.
Wait, so, like, expectations.
Yes, the blanks are Z-score. We're looking at the 1% most extreme values. Okay, the 1% most extreme values doesn't have anything to do with the 25.5 or the 3, just yet. You do not need the 3 or the 25.5. Yes,
When
David?
we calculate the z value, do we use the norm or do we use the t dot?
We're doing norm.s at this point. Yes. We're assuming that we know the population standard deviation. And let's find those 1% most extreme. So if you have 1% most extreme values, what sides are they going to be on if it's 2, 2? Where are the extreme values? Are they in the middle or are they on the sides? Good. This is going to look really familiar. We've actually done this already.
Alright, so 1% most extreme, but that would just be the bottom 1%. So you do norm that as that point.
Yeah, this one's
What does that give you?
Negative.
Like, what's, like inverse or this?
Inverse. Because it gives the score of the extreme.
That gives you this.
Yeah.
Thanks, sir.
Good. So you guys got this. Extreme values should be on the side, which this is not extreme.
So this one's right?
This one's right, this one's right.
So is it gonna be from here?
If it's right tailed, then it's just gonna be the small little right.
Oh,
So it is between negative and positive and negative and positive.
Oh.
Are these values right?
This one's right, these two need to be rechecked. What number did you put into here?
Because isn't it just the same with the z values?
No, because this one, the 1% gets divided in half, half on both. This one, just 1%. Okay, let's just go ahead and go over this. Okay, if you have 1% and it's two-tailed, what percent do you have on both sides? Michaela and Andre.
Yeah.
I know you guys got this right, but we want to just double check and confirm that we do have it correct. It's 0.05 or 0.005 on both sides. Why is it 0.005 on both sides? Good. Half of 1% is 0.005. Okay, now if we do this in Excel, it's norm.s.inverse of 0.005, and that gives you negative 2.58. So this one's negative 2.58. And then how do we get the other one? Norm.s.inv of 0.995, which will be 2.58. Okay. Left-tailed test. Where is the most extreme values in a left-tailed test? Is it on both sides? No, it's just on the left side. So it's 0.01 over here. What do? Norm.s dot INV of 0.01. I don't remember what this value is. I know that 33, negative 2.33, okay. Okay, right-tailed test, where are the most extreme values? Over here, 0.01. Norm.s.inv of the left area is 0.99. If you have 0.01 on the right, you have 0.09 on the left. We already know what this value is going to be, though. It's going to be positive 2.3. Okay, what symbol do we give this? We call this the significance level. The percentage of most extreme values is called the significance level. So this 1% here is what we call the significance level. And it's the 100 alpha percent, so we can use a symbol here for it. Let's put it in decimal forms. Let's do a think, pair, share. What symbol do you want to give the significance level? It's just alpha. And what's the alpha? The alpha is, I don't want to use percentage. So what do I want to put here? 0.01. Good, Michaela. Okay. Are we still going to reject this null hypothesis? Yes or no, and why? Remember the z value here was 3. So think, pair, share. The z value is 3. Basically, is the 3 an extreme value? The big question is a z value of 3 considered as an extreme value? I'll say that one more time. Is a z-score of 3 considered an extreme value? I want us to all write an answer for this. Are we going to still reject? We got a z 5.5 at a z value of 3. And the extreme values, should be below negative 2.5. Okay, I just realized I have a mistake on the worksheet. This should not be between negative 2.58 and positive 2.58, because are these the extreme values? Are the extreme values between here and here? No, it's below here and above here. So this should not be between, it should be below negative 2.58 and above 2.58. Those are the extreme values. So quickly as a class, why do we not want to change our answer? Why do we still want to reject? Good. What was the z value? 3. Is 3 considered an extreme value if extreme values are above 2.33? Yes, or 2.58, sorry. Extreme values are above 2.58. 3 is above 2.58, so therefore we're rejecting. Okay, any questions on that process? We're going to do 2 examples now on these, and we need to get through both of these or the homework is going to be hard. So let's start with number 10. You want to make sure that you do all 4 steps of a hypothesis test. First, you want to set up your null and alternative. And then find z value, and then is Z-value extreme, that's a big question. That means you have to find what is considered extreme values. And then make your decision. Make rejection decision. If you want to just go ahead to the pair part of the think, pair, share, just go for it, because I think we need help.
Okay.
The sample mean is 182. We're testing to see if the population mean is different from one predicate.
And how do we know if we want to use right field or left field?
It says different from one predicate.
Wait, mu is less than 1. So is it the sample?
Fail.
That's
Right, left, both, to them.
Population mean is
It's a really heads up to me, like the first thing is doesn't really understood it.
Oh my god. Why do I know how I write this now? I literally just wrote it.
I said it doesn't change because the value is still like.
Yeah, because we're looking to see if it was right tail, then it would be like this.
So it's just
Not.
you were just doing, you read the
Means
dash,
not.
the dash, like 182.9.
So.
You need to set up your null and alternative hypothesis. So
Okay. So.
yes. Yes.
What's the summary here for?
The significance level is 0.01. So you can just kind of change.
What?
Yeah, I'm trying to read it.
So is it
Yeah, it's still, or yeah. It's 2 tails, so it's 2.58 one is considered extreme.
But wouldn't it be both if it's below and then above?
Yeah, anything, if it's below 2.58 or sorry, above 2.58 or below negative 2.58. Okay, so these are the extreme C values, but I want us to find the C values too. We take the sample mean. So how do we find using the Z score? Yes. That's the extremes, or the extreme Z
So
score is
it's
2.1.
121.8 over the square root of 54.
The Z score is X minus, well, X bar. It's X bar minus the mean of X bar divided by the standard deviation of X bar.
Add that to 150 and it goes above. We know that it's not extreme.
How do you think it's
2.58 was from here, it's just, it's a two-tailed test.
Did he talk
It's two-tailed because,
Okay, now.
it doesn't say greater than or equal to, it just says given from, so it's gonna be two-tailed. It was less than that, you left it.
That's find the extreme. Find the actual Z value. Here's the formula X. Minus 22.
Really, X bar though?
X bar minus
We have a
X bar.
sample situation. Because it's when we find isn't that usually? Because you know how
You know
we
X bar is population. X bar is population.
Wait, this is cool.
That's correct.
You still have to do.
And don't forget to divide.
Okay, what you oh, yeah. Wait, so it's.
Oh, no, the Z-score is not extra.
The Z score should be 1 point something.
So it's not extreme. The extreme is like 2. Oh, I didn't. So I just saw it on the extreme. Like these are the extreme. So it's like, it doesn't fall outside of these.
Okay, let's do it. What are we assuming that the population mean is? Good. And we're testing to see if it's different from 150, so it needs to be not equal to 150.
Wait, what's the answer 1.9?
Yeah, then I think that it's the Z value, yeah. Okay, so our Z value formula is X bar minus the mean of X bar over the standard deviation of X bar. And that is 182.9 minus 150 divided by 121.8, but what do I have to do to the standard deviation? Divide by the square root of 54. So I'm going to type all of this into Excel, and I'm going to show you how to do this in Excel so you don't have to do it like in different steps. All you have to do is to literally type this big expression in. So this is how you do it. I don't want people to waste time typing it in separately. It's so much easier just to do it like this. So you're going to hit equals 182.9 minus 150 divided by parenthesis 121.8 divided by SQRT of 54 parenthesis.
Again, what was the advantage of writing it in like this? Do I have to find the standard deviation separately before typing it in again to Excel? No, you can just immediately type everything in like this.
After you do that, you get 1.98. So the Z value was 1.98. Okay, we were using a significance level of 0.01. What are extreme Z values for two-tailed and 0.01? Below negative 2.58 and above 2.58. Is 1.98 considered an extreme Z value? No. Not an extreme Z value or Z score. So are we going to reject? No. Fail to reject.
Wait, why is it not extreme?
Because the extreme Z values are either below negative 2.58 or above positive 2.58. Now this is assuming 1% significance level. In the homework, the significance level could be like
Different, but do we know how to find them for different significance levels? Okay, okay, good.
So fail to reject. Okay, let's try number 11. It's the same thing except it's less than 500,000. Less than is what tailed test if it's less than. Left-tailed.
No, it's not that.
Oh, wait, you only square root the 40, you don't square root
Oh, yeah, I don't know why, yeah. So if the number is under.
the extreme value for the alpha. So it's not the alpha itself, it's the, you have to turn the alpha over the extreme. So if it's under the C, which is down the alpha. Chart. And that's you know, it's the 1.98.
It's the left tail.
It's not.
Is it when you rejected? Because it's like
You're gonna reject.
So this is like
What number did you get?
negative, negative 1.14.
They're getting it like
If
negative.
it's negative, it's a lot, please type it, and the rest of it. I read
Yes.
So the bottom would be that is divided by square. So it's like that.
So, yeah, we're also using a different square.
So it's
Like on mine,
yeah, like
it'll
it's like
Okay, we're now doing 4% significance. So I want us to change these all for 4% significance. So I'm gonna erase all of this.
So that's this value is this.
And it's left-tailed, so I'm gonna use the left-tailed one. I guess I'm not having time to do all three boxes, but we'll do the left-tailed box. If our left-tailed test, where's the 4% extreme values? Good, and this value here is going to be 0.04 norm.s.inv of 0.04, and you get negative 1.75. So anything less than negative 1.75 is considered an extreme value. Okay, let's now do the problem. H0, H1, mean is equal to 415953. Mean is less than 415953 because it's left-tailed. Okay, next let's find the z-value. The z-value uses the sample mean. Oh, I did not do this right. My bad. Let me correct that. The population mean goes here. What's the population mean? 500,000. So this has to be 500,000. Okay, now the z, I'm going to take the 415953 minus 500,000, divide by the standard deviation, which is 463,364 over the square root of 40, and I believe I get negative 1.14. Okay, is negative 1.147 considered an extreme value? Not extreme, because extreme would have been less than, good, anything less than negative 1.75 is considered extreme. Not extreme, if it's not extreme, I'm going to fail to reject. When do we reject? If it is, we fail to reject when it's not extreme, and we reject when it is extreme. Okay, this video will be posted on YouTube. Homework posted by 2 p.m. Bye, Audrey.